Okay, welcome back to part 2 of this series in Python testing. So in the first example, we wrote a function that produces the cube of a number. And we wrote a test for that, where we're checking that if you give the number 2 to your cube function, that the result will be 8. And we ran that, it passed, that's brilliant. But there's limitations to that approach because, as you can see, you're only testing one use case when the number is 2. And so the question becomes, if you can think about it, what happens if you give it a negative number? Or what happens if you give it the number 0? What happens if you give it a really large number? There's like a variety of cases that you want to test and put your function through to make sure it's working as expected. And so the previous example kind of is limited in that way. And this is where pytest parametrization comes in, which basically enables you to run a series of different test cases and check them as a test separately. So we'll start with that to begin with. So what you want to do is just set up your test function. Test cube function is correct. And call it v1 here, purely because there's a couple of other extensions that I want to show you, and I'll name those functions v2 and v3 just for ease. Right. So before I dive into the code, we know that the standard approach is to use your function, take that result, and check it matches an expected result. But to parameterize your code, you're going to leverage what is called a fixture. I won't go through what fixtures are in this video. You can look them up. I might do a video on them at some point, but just know that if you use this fixture, you can parameterize your code. And basically the syntax is to first give it the name of parameters that you want to use. So what we're going to do is we want a parameter for the input that we want to feed in. So we want to feed in different inputs. And then we want to give it a parameter of what we expect the result related to that input will be. So I'll call that expected. And then you give it a list of any number of test cases that you want to supply. And so we're going to put this inside tuples. And so just before we had 2 as our test input, 8 being the expected result. So that's one test case, if you will. And so, as I said before, we could do 0, and that should equal 0. So that's trying something different. We could try -2, and we should expect that to be -8. And we could also do 10, and that should be 1,000. So you see you've got 4 different test cases. Each time they get fed into these 2 parameters, which we then need to feed into the function. And then we can kind of write the function just like you in the same setup we kind of saw before. So right, if you take the result equals using the cube function, feed into it the test input, grab it as the result, and then assert that the result is equal to what we expected. Right, so in the first iteration it's going to feed in 2 here. We're going to cube it and check that that result is equal to 8. And then it will do the second one, the third one, the fourth one. And so if you allow me to run pytest, you'll see 4 tests have passed. So what I'm going to do here is just add the verbose flag in the command line, and all this means it gives you a slightly bit of extra information. And so you'll see here that we have run the v1 test function 4 different times, and it gives you a hint as to what values have been used in that parameterization. So if for some reason the third one failed, let me just edit that. You'll see here oh, you can look at the log and say, okay, it was the -2 case that failed, and you'll get some details that you can kind of go on to go and solve that issue. So that's the most important, really easy way to parameterizing your code. Now, the final thing that I want to show you is essentially a bit of housekeeping, if you will, for your test functions. So as you can kind of see, it could easily become a large number of different test cases. And if you've got a large code base, many functions with many test cases, it can become quite convoluted in terms of understanding what each test case is doing. And so what you can actually do is kind of add IDs to your test cases. So what I'm actually going to do here is, just for ease of readability, is say, here's my test data. So I'm going to basically pull out these examples. Whoops, yep. And 10 and 1,000. And so what I can do is lump that in here. So that's my test data. So it just makes it a slightly more readability. And you can add IDs to each substandard test, right? So what I'm basically doing here is kind of covering all the different test cases, scenarios that this function could take. So a positive integer, 2, what does that work? Or if I give it a 0, I'm going to label it as 0, does that work? If I give it a negative integer, and then if I give it a large integer, right? So if I do that, I will run it. I'm going to look for this function v3. Sorry, I didn't rename it to v3. So what you'll see here is now there's like an intuitive ID to each test function. So, okay, v3 worked with positive integers, it worked with zeros, it worked with negative, worked with large integers. And so you now have if you're running a code base and suddenly something fails, like we said before, you can read the log and you'll see, oh, it's negative integers that this cube function is not handling correctly. Let me go investigate. So that brings me to the end of this second part of the Python testing tutorial. Hopefully it will really step up your game in terms of testing in Python and enabling you to quickly run tests against all the different scenarios, all the different corner cases that you can think of for your function. That is the value of parameterization. Okay, before I go, if you did enjoy that video, please give it a like, consider commenting on what you found useful, and consider subscribing for more videos like this one. Thanks, guys.